Hello, my name is Ritik Bansal, and I present to you Perio Vision, which is my use of using AI to revolutionize gum disease detection. My main goal was to solve a disease called periodontitis, which is a severe gum infection that damages soft tissue and often remains undetected until advanced stages. It's the primary cause of tooth loss worldwide, and it can also have systematic effects such as increased risks of heart issues like arthritis, heart disease, stroke, and even diabetes. This also isn't a very small problem. In fact, almost half the adults aged 30 and older have some sort of this gum disease, with prevalence increasing with age, around 70.1% for adults 65 and older. My inspiration for this project was my grandmother who suffered from this disease. She lost all her teeth and developed heart disease in the process. And it wasn't diagnosed for her because of the unnoticeable symptoms that comes with this disease and the limited access to healthcare she had in India. Current diagnosis is only using x-rays and probes. So it costs around $200 to $400, which is way too expensive for some people in third world countries. I want to create a new solution using AI that could do it for practically no cost. So my main question when designing this was, can I use specific visible differences between healthy and unhealthy gums as early indicators for the presence and progression of periodontitis? Currently, I've only implemented the detection stage, but in the future, I want to implement monitoring. For detection, the user is going to import an image into Perio Vision, to which it'll tell them if they have positive periodontitis or negative. For monitoring, they're going to put images over a span of many, many months, to which Perio Vision will tell them if their periodontitis is deteriorating or if it's stable. So my methodology was basically like, I was pretty sure that we could use computer vision with visible differences between healthy and unhealthy gums to determine gingivitis and periodontitis without any clinical aid. Some of these visible differences are plaque and tartar buildup in the first image, brighter and darker red gums in the second image, receding gum lines, and black triangles. So when looking on Kaggle for a relevant data set, I found absolutely nothing. So I had to take it upon my own hands to collect my own data. So for diversification, I collected data using two types of participants. One were dental clinics, where I asked them for anonymous intraoral pictures from unhealthy and healthy patients. I also asked individual participants, where they were asked to insert a cheek retractor, provided them, and take a picture, which would be sent to me securely via Google Form. I also had to create research project consent forms to overlaw HIPAA laws that came in my way. At the end, I had around 156 images. I split these images using an 80-20 split, to which 80% was used for training and 20% was used for validation. So some tools and technologies I used. So my coding platform was collab.research.google.com, where I wrote and executed code. The algorithm I chose was a convolutional neural network, or in other words, a CNN. And the reason I chose this is because it has multiple layers that apply filters, which can attract features from your image data. The library I used was FastAI, which is basically a library that makes it easier and faster to build these types of models. My approach was transferred learning. Because I didn't have the thousands upon thousands of images needed to complete a CNN architecture, I had to use transferred learning, which involved taking a model that had already been trained on a large data set and repurposing it for my own. The repository I used, or in other words, the comprehensive data set that these models were trained on, was ImageNet, which has around 1,000 classes and over 1.5 million images. The models I used were ResNet 18, ResNet 34, and BGG 16. So how I evaluated my model's performance. One metric I used was recall, which is the ratio of true positive instances to the sum of true positives and false negatives. I used to use loss, which is how well the model's predictions match the actual targeted values. The goal is to minimize the loss and increase the recall. When comparing three models after training each one of them, I saw that ResNet 34 had the highest recall and the lowest loss, with an intermediate time of run, around 11 seconds. So this is some of my code that I wrote. I decided to just put this in the slide, but I could show you this in a Jupyter notebook that I created as well. So yeah. So for initial training, first I only trained one layer out of the 34 layers ResNet 34 provides. And I didn't get very good results. As you can see, our recall was only around 0.3. and we had high amounts of loss with okay runtime. In the confusion matrix, we see a high number of false negatives and false positives compared to true negatives and true positives. Being disappointed, I decided to unfreeze the other layers to see if my data could reach further into the resonant model and potentially provide better results. With this, we saw a tremendous increase in recall and a much lower loss rate. In the confusion matrix, we see a high number of true positives and true negatives compared to false positives and false negatives. So this is the real classification data set that got output to me from the 80-20 split. So this is around 20% of my images. As we can see at the top, we have an actual label of what the image actually is. At the bottom, we have the AI predicted label. We see 3 of these images are wrong, this one, and this one, if you guys can see my cursor. But that kind of represents our 90% accurate results, 3 out of 30. So some limitations were that it was only conducted with 156 participants. I would like to have more participants in the future. And most of these participants were from the Seattle area, so it was missing a geodiverse data set. Obviously, tooth bone loss and x-rays were not included into classification because you can only measure that via x-rays, and probing depth was also not measured as you need a dentist for that. Overall, however, we realized that we can indeed determine periodontitis using AI models with 90% accuracy, even with the limited data set. I'm sure if we got more data, we could bump this 90% accuracy even higher. But transfer learning techniques were also useful, and modeling can be done with intraoral pictures captured at home via smartphones. This has the potential to save many, many lives in third world countries, or whether you're just lazy and don't want to go to a clinic. So yep, they can be done without x-rays, dental probing, or clinic visits. Here are my key references, and I'm ready for any questions you guys may have.
So you said it was like really hard or very expensive to like test for periodontists like in an actual clinic. Do you
Yeah,
think that you could make this accurate enough to just be able to use this, or would you still recommend that people should spend that money and get themselves tested as well?
so obviously this isn't going to be 100% accurate, but considering I only had 156 images and my accuracy was pretty high, I feel like if I got a lot more images, for example, 200, 500, maybe even 1,000 in the future, I could get that accuracy almost like 95, 97%, to which it would be really good predictor. But obviously it's not going to solve your periodontitis. It's more built for awareness. Like for example, my grandmother, she didn't have access to something like this, so she was never aware of her periodontitis until obviously all her teeth fell out. So I mainly built this more for the awareness aspect so people could kind of know if they had periodontitis or not and then take further actions. I do want to turn this into a mobile application. So because currently right now it's just in a Jupyter notebook, but I want to turn this into a mobile application so someone can just scan their teeth, it would tell them if they have it or not, and then potentially provide further steps that they may need to take.
So this is
Okay,
more of
I don't. Hmm?
sorry.
Oh, you
So
go
this
ahead.
is more of a So this is more of a plan to help someone detect if they might have this disease and then forward them to someone who can help them.
Yeah, yeah. More
All
of
right.
a awareness type.
Okay, yeah. So I have a comment actually, not a question. So me and the judges believe that you did your data and research very well, and I also like that you used some sort of issue that was personal to you as motivation to pursue research in this topic. So I think you did well on that end, and you made your presentation well.
Thank you, thank you, thank you. Yeah, I have this Jupyter notebook pulled up that I kind of created here. So, I mean, I was just kind of playing around with the data, training the model, and yeah. And then if you guys want to see my data set, I could show you guys that too, but yeah.
I just have another question.
Yeah.
How easily do you think that you could expand this to other diseases or like use this to scale to identify other diseases like this one?
Oh, okay. Yeah, so currently in the dental industry, there aren't as many like, like major diseases compared to periodontitis, but obviously if I had the data, which obviously we could probably get, I could easily scale this to potentially detect, for example, like cavities or some other disease. It's mainly just about how much data I can have, and I would just need to build another module within this.